I'm walking you through the entire process of the video analysis tool with the advanced capabilities that I'm going to share with you. So first of all, you go to Projectile Spring 18, and there's this weird document that looks blue. It's called the Video Analysis Practice 1. Please download that. Once you download it, it should automatically open. So save it somewhere. Then you should open it. Once it downloads, pause. All right, it's downloaded. Now it's going to open up on my screen, I hope. So if it doesn't, aha, there it is. Okay, it should look like this. Note, this is a launcher, so what you can do, if you want to see what I'm talking about, if you hit play, it's set in slow motion. So someone took it with slow motion video, but you can still kind of watch the time. So notice it gets launched up, does that parabolic shape, and comes back down. Beautiful. Okay, so what we're going to do is we're going to select measurements. First, it should be time here. Should be time here. Next, turn on video analysis. Grab your calipers. Match it to the length of the track. The track is a meter, 1.25 meters. So double click on the length and check that. It should say 1.25. Then backtrack this until you see the ball just barely coming out of the launcher. So right about there. Okay. Select measurements. The bottom measurement should be object 1. The X component, that's the horizontal component. Do the object 1. Y component, that will be the vertical component. Okay, cool tool. This, it says enable auto tracking. If you see, it's going to come up with this circle. Okay, this circle is finicky. Grab it with the open hand and put it around your ball. Kind of try and shrink it around the ball to the best of your ability. If you need to, okay. So, and then test it. See, it did. It's auto tracking. So once you hit start, let it auto track all the way up. This saves you a lot of time and energy doing all those clickings. It just tracks every single motion that it does. It's not perfect, but nor were you when you track this. Make sure you hit stop when it reaches the cup back at the bottom. Otherwise, it's going to give you some really wonky, ridiculous data. So you're going to watch, track, all the way down. Best feature ever. And stop. See how it started tracking over here? So what you're going to want to do is kind of reverse. Oops, I went too far. Play. See if it'll. There it goes. So as you run it, just pause it earlier. Okay, so reverse it back so you lose. Like backtrack it until you get back to data that actually is relevant. So right there. Then hit done. Okay, there's your nice look. It's a parabola like we've been talking about. Okay, so some other tools. First, you have a beautiful looking graph. Notice this is a nice linear equation. You can zoom in and drag it into the center of the screen and then zoom. So you see, it shows a nice linear equation, and look, this shows a nice parabolic equation. So that accurately represents the horizontal and the vertical motion. Remember, this nice flat line indicates a constant velocity. Next, I want you to use this measurement tool. Choose measurement. I want you to figure out the distance between the start and the finish. All right. Then I also want you to figure out the height of the parabola. So distance tool again, go from the yellow line, go all the way up. How high was that? Because when you do this with your athletic balls, you need to figure out what the distance is so you can calculate free fall, and you're also going to have to track the time here. Okay. Another nice tool that you're going to need is to figure out the angle of the throw. So when you do the throwing action, you're actually going to have to take the time and figure out the angle. Here, this angle is, I don't know, I'm just making it up because the angle is irrelevant here since it was thrown up at pretty much a horizontal. So technically it should have been right about a 90-degree angle, right? Because that's what it was thrown up at. And then it traveled in this parabolic path. But when you measure it, you need to figure out the angle that the person threw the ball. So was it a big angle or was it a narrow angle? So I need you to calculate that. Okay, once you do that, the last thing, a last easy tool is if you choose, I care about this one, the X position. Grab this line with the highlight range of active points. So I want you to grab the box, click on that. We're going to pick this range and we're going to figure out the linear slope. So once you do the box with the select tool, you're going to choose linear and it's going to run a trend line through your data. And that trend line tells you that the velocity of this ball is about 0.05 meters per second. Remember, and that's plus or minus 3.4 times 10 to the negative fourth. So that's move the decimal place 4 places to the left, and that's the degree of like correctness. But remember, m is the slope. So the average velocity here is 0.05 meters per second. Notice I'm giving you all these tools so you don't actually have to run all the numbers. Okay, you don't need to do that for this, but you do need to choose File and Save. You should have your very own experiment saved to your desktop. So File, Save As. So trial run of launched ball KS. I'm putting my initials on it because I did the work and saving it in my projectile motion folder. Excellent. So now when you come to class, this is what I should see. I should see this done correctly. The calipers at 1.25 meters, measuring the entire length of the track. Should see your X and Y axis in here. I should see a distance between the start and the finish. I should see a horizontal distance to see how high the ball went. And I should see the angle tool thrown in here somewhere. I don't really care where it is. I just need to know that you are capable of putting an angle in. Look, there's a weird angle because this will be imperative that you know how to measure the angle of your throw using these tools. And then you should have your graphs. This one and this one. I'm not even making you graph it in Excel. Right? Thanks, guys.